Hello students, this video is about question and answers of the class 6th science chapters.
Chapter 6 Motion and Measurement of Distances. First we will see the exercise questions of this chapter. Section A Multiple choice questions. Select the correct option. First question, the motion of the wheels of a horse driven cart is rectilinear, curvilinear, rotational and translatory, circular and translatory. Answer is rotational and translatory. The motion of the wheels of a horse driven cart is rotational and translatory. Second question, the motion of second hand of a clock is circular, rotational, translatory, curvilinear. Answer is rotational. The motion of second hand of a clock is rotational. Third, the free fall of an apple from a tree is either rotational motion, rectilinear motion, periodic motion, none of these. Answer is rectilinear motion. The free fall of an apple from a tree is rectilinear motion. Fourth question, which of the following is not in periodic motion? A fan moving at constant speed, a swinging pendulum, rotation of earth, a flying kite. Answer is A, flying kite. Flying kite is not a periodic motion. Fifth question, a rolling ball shows rotational motion, translatory motion, both A and B, periodic motion. Answer is both A and B. A rolling ball shows rotational motion and a translatory motion. Sixth question, which of the following can be used to measure the distances between two heavenly bodies? Second, kilometers, light year, pounds. Answer is light year. Light year is used to measure the distances between two heavenly bodies. Seventh question, the number of grams in 1 quintal is 100, 1000, 10,000, 1 lakh. Number of grams in 1 quintal is 1 lakh. Eighth question, which of the following is not matched correctly? Volumes, liters, time, Kelvin, mass, kg, length, meter. Answer is time, Kelvin. Because time cannot be measured in Kelvin, but temperature is measured in Kelvin. Time is measured in either seconds, minutes. Ninth question, which of these is translatory motion? Rectilinear, curvilinear, random, all of these. So all of these is the answer. Rectilinear, curvilinear, random motion, all are these are type of translatory motion. 10th question, the motion of a pendulum is? Motion of pendulum is oscillatory motion. Answer is option C, oscillatory motion. Section B, fill in the blanks. First one, the dash is the standard unit of mass in SI system. Dash is the standard unit of kilogram is the standard unit of mass in SI system. Kilogram is the answer. Second one, the pendulum undergoes dash motion. Pendulum undergoes oscillatory motion. Pendulum undergoes oscillatory motion. Third, the motion of the earth around the sun is dash in nature. The motion of the earth around the sun is revolutionary in nature. Revolutionary in nature. Fourth, 1 meter is dash centimeter. 1 meter is 100 centimeter. Fifth, 5 kilometer is dash meter. 5 kilometer is 5000 meter. Sixth one, motion of a child on a swing is dash. Motion of a child on a swing is oscillatory motion. Oscillatory. Seventh, motion of the wheel of a sieving machine is dash. Motion of the wheel of a sieving machine is periodic. Eighth, motion of the wheel of the bicycle is dash. Motion of the wheel of the bicycle is rotational motion. Rotational. Ninth, dash is a standard unit of measurement. Meter is the standard unit of measurement. Section C. State true or false against each of the following statements. First one, the repetitive motion is that which repeats itself after regular intervals of time. Answer is true. Second one, all periodic motions are repetitive, but all repetitive motions are not periodic. This statement is also true. Third one, handspan is the distance between the tip of the middle finger and the elbow. False. Fourth one, pathom is the length of outstretched arms. This statement is true. Pathom is the length of the outstretched arms. Now fifth one, knowing how far a place is can help you decide which would be the best way to reach there. True. Sixth one, 100 meter makes 1 kilometer. No, 1000 meter makes 1 kilometer. That's why this statement is false. Now seventh one, kilometer is the SI unit of length. Kilometer is the SI unit of length. It is false. Meter is the SI unit of length. Now eighth one, any type of motion that does not repeat itself after equal intervals of time is non-periodic. This statement is true. Now ninth one, what is ninth? Motion of the earth about its axis is rotational as well as periodic. This statement is true. Motion of the earth about its axis is rotational as well as periodic. 10th one, a child coming down a slide has rotatory motion. Answer is false. Section D, Match the items of column A with those of column B. Length. Length is a distance between 2 points. Length is distance between 2 points. Second, change of position with time. It is motion. Change of position with time is motion. Third, periodic motion. Periodic motion repeats itself. Unit of length is meter. Unit of length is meter. Pendulum is oscillatory motion. Pendulum is a oscillatory motion. Heartbeat, it is a periodic motion. Heartbeat is periodic motion. Potter's wheel is rotatory motion. Ball rolling on the ground is a translatory motion. Section E. Show the differences and similarity, if any, between the following. First one, rest and motion. Second, periodic motion and repetitive motion. Third, vibratory motion and oscillatory motion. Fourth, movement of the earth about its axis and the movement of a rotating top. Fifth one, the motion of the birds in the sky and fish in a pond. So we will see the answers of these questions one by one. First one is rest and motion. What is rest? First difference is rest. What is rest? The position of an object not change with time. Next is motion. What is motion? The position of an object change with time. Second difference is periodic and repetitive motion. What is periodic motion? The motion which repeats itself after a certain fixed interval of time. What is repetitive motion? Repetitive motion is these motions are repetitive but not at regular intervals of time. Third one, vibratory motion and oscillatory motion. What is vibratory motion? An object vibrates to and fro very fast. Rapid oscillatory motion is called vibratory motion. Next, what is oscillatory motion? What is oscillatory motion? The to and fro motion of an object about its position of rest is called oscillatory motion. The to and fro motion of an object about its position of rest is called oscillatory motion. Movement of the earth about its axis and the movement of a rotating top. Movement of a earth about its axis, this is a periodic motion, whereas movement of a rotating top is non-periodic motion. The motion of the birds in the sky and the fish in a pond. Motion of the birds in the sky is a kind of translatory motion, and motion of a fish in a pond is also a kind of translatory motion. Section F, give reason. First question is, we say a tree on road is stationary, but when we are in the moving train, we see that trees are moving fast in the direction opposite to that of the train. Second, all periodic motions are repetitive but all repetitive motions cannot be periodic. Third one, we cannot use a pace or a footstep as a standard unit of length. So we will see the reason of these three questions. First question is, we say a tree on a road is stationary, but when we are in the moving train, we see that trees are moving fast in the direction opposite to that of the train. Answer, rest and motion are relative terms. Rest and motion are relative terms. When we are in a moving train, it seems that trees are moving fast in the direction opposite to that of train because it appears that we are in rest with respect to the train. Because it appears that we are in rest with respect to the train. Second question, all periodic motions are repetitive, but all repetitive motions cannot be periodic. Answer, all periodic motions are repetitive motions, but they cannot be repeat their motions after a fixed interval of time. In case of repetitive motion, it repeats its motion at any interval of time. Third one, we cannot use a pace or a footstep as a standard unit of length because length of pace or a footstep can change from person to person, so it cannot be taken as fixed quantity needed for a standard quantity. Section G, very short answer type questions. First question, name the motion each of the following. A child swinging the wheels of a car. Second question, what is the full terms of CGS, FPS, MKS, SI? Third question, why do we need to measure length or distance? Fourth one, can an object have more than one type of motion? Give two examples. Fifth question, what is the need for standard units of measurement? Sixth question, what is rotational motion? Give two examples. Seventh one, how did people measure length in early time? So we will see the answers of these very short answer type questions one by one. First question is, name the motion each of the following. Child swinging. Child swinging is a oscillatory motion. Second one, the wheels of a car. Wheels of a car is rotational motion. Second question is, what is the full terms of CGS? CGS means centimeter gram second. FPS means foot pound second. MKS means meter kilogram second. SI means system international de units. It is in French. Third question, why do we need to measure length or distance? Answer, we need to measure length or distance to calculate the accuracy and reliability of the object. So why do we need to measure length and distance? To calculate the accuracy and reliability of the object. Fourth one, can an object have more than one type of motion? Give two examples. Answer, yes, an object has more than one type of motion at the same time. Example of this kind of motions are the earth rotates about its axis, rotational motion, and the earth revolves around the sun is a translatory motion. Another example, a moving top has rotational and translatory motion both at the same time. Fifth question, what is the need for standard units of measurements? Answer, in order to get the accurate measurements, we must use a fixed unit of measurement whose value does not change when used by different individuals in all over the world. So, a standard unit is needed. So, what is the need for standard units of measurement? For accurate measurements, we must use a fixed unit of measurement whose value does not change when used by different individuals in all over the world. So, standard unit is needed. Sixth question, what is rotational motion? Give two examples. A motion in which body moves about a fixed axis without changing its position is called rotational motion. The motion of blades of the table fan. This is one example. And another example is the motion of hands of a clock. Seventh question. How did people measure length in early time? Answer. In early times, people used to measure length with the help of handspan, cubit, and pathom. So these are the basic traditional measurements. Section H, short answer type questions. First question is, how will you measure the length of an object using a measuring tape? Second question is, state 4 precautions that you should take while measuring length with a ruler. Third question, describe the measurement of a curved line with the help of a divider. Fourth one, name the different types of translatory motions and explain in brief. Fifth one, state two similarities and two dissimilarities between the motion of a cycle and a ceiling fan that has been switched on. So we'll see the answer of these questions. First one is, how will you measure the length of an object using a measuring tape? Answer, we take a measuring tape, the zero mark of the tape coincide with one end of the object and the reading at the other end of it gives the length of the object. So we take a measuring tape, the zero mark of the tape coincide with one end of the object, the reading at the other end of it gives the length of the object. Second question, state 4 precautions that you should take while measuring the length with a ruler. Answer, precautions taken while measuring length with a ruler. First is, keep the ruler along the length of the measuring object. Second is, if the edges of the ruler is worn out or broken, the measurement should be started from any other clear mark. So if the edges of the ruler is broken out, then start the measurement with any other clear mark. Third one, put the eye normally to the mark. Fourth, a ruler with the marked and leveled or tapered should be used. Third one, describe the measurement of a curved line with the help of a divider. Answer, steps for measurement of curved line with the help of a divider. First, open the legs of the divider and measure the distance between 2 points with a ruler, say 5 mm. Place one pointed end of the legs at one end of the line and put the other end along the line. Third, rotate the divider along the second leg and put the further along the end. Count the number of times in which it covers the entire length of the line. If a small portion of the curved line is left out, measure it separately by adjusting the legs of divider. Now add this distance to the distance observed. Now length of the curved line is equal to number of steps into distance between legs of divider plus length of leftover segment. So what is the length of the curved line? It is a number of steps into distance between legs of divider plus length of leftover segment. Fourth question, name the different types of translatory motion and explain each in brief. Translatory motion has two kinds. Rectilinear motion, that is when an object moves in a straight line, it is said to be in rectilinear motion. An apple falling from the tree and a train running on straight track are the examples of rectilinear motion. So what is rectilinear motion? When an object moves in a straight line, it is said to be rectilinear motion. Second is curvilinear motion. What is curvilinear motion? When an object moves along a curved path, it is said to be in curvilinear motion. So when an object moves along a curved path, then it is said to be curvilinear motion. Examples are a stone thrown up in the air at an angle and a bus taking turn are examples of curvilinear motion. Fifth question, state two similarities and two dissimilarities between the motion of a bicycle and a ceiling fan that has been switched on. Similarities, both are in motion, and second similarity is wheels of the bicycle and blades of the ceiling fan both are in rotational motion. And dissimilarities are bicycle is in translatory motion while ceiling fan is in rotational motion. Bicycle changes its position during motion while ceiling fan does not change its position during motion. Section I, long answer type questions. First question, what is the need for measurement? What are standard units and why are they important? Second, is your house at rest or in motion? Explain briefly. Second, when is a body said to be in motion with respect to an observer. Give one example. Third bit, is it possible for a body to appear to be at rest to one observer and appears to be in motion to another at the same time? Give examples. Third question, fill column B with the words given in the box below. So you see the answer of these questions one by one. Long answer type questions. First question is, what is the need for measurement? What are standard units and why are they important? Answer, there are so many occasions when we come across a need to measure length and distances. The tailor needs to measure the length of the cloth according to requirement of fitting. Similarly, a carpenter needs to measure length and breadth of the door to calculate how much would be required to make the door. Thus, need for measurement must have arisen out of everyday activities. In 1960, General Conference on Weights and Measures was held by the scientists of all over the world. They recommended a common system which should be used for the sake of conformity. This system is known as the International System of Units, that is SI unit. The SI system has six most common basic standard units used in our daily life. In order to get the accurate measurement, we must use a fixed unit of measurement whose value does not change when used by different individuals in all over the world. A standard unit is needed. Second question, is your house at rest or in motion? Explain briefly. Answer, my house is in rest because its position does not change with respect to time and in comparison to the surroundings. B. When a body is said to be in motion with respect to an observer, give one example. Answer, when position of a body changes with respect to an observer, the body is said to be in motion. For example, an observer standing on a roadside sees a car running on the road. C. Is it possible for a body to appear to be rest to one observer and appear to be in motion to another at the same time? Give examples. Answer, in a moving bus, a passenger is considered at rest with respect to his fellow passenger, while in motion with respect to objects lying outside the bus at the same time. So whenever passenger is sitting inside the bus, he is at rest to the with respect to the fellow passenger. But for the outside people, he seemed to be moving. Third question, fill column B with the words given in the box below. Mass, mass has a weight. Meter, it is a unit of length. Inner volume contains capacity. Inner volume contains capacity. Distance between two cities, is measured in kilometer. Time, it is a periodic event. Time is a periodic event. SI unit of volume is liter. SI unit of volume is liter. Melting point of ice is 0 degree Celsius. Melting point of ice is 0 degree Celsius. Kelvin, it is a unit of temperature. Kelvin is unit of temperature. Section J, diagram based questions. First one, which part of the moving bicycle shown in the figure alongside undergoes rotary motion? Here hint is also given. The wheels of a moving bicycle are moving around on an axis passing through itself. Such a motion is called rotational motion. So even though cycle is moving in a straight line, the wheels undergo motion too. Answer, which part of the moving bicycle shows the figure alongside has a rotary motion? The wheels of a moving bicycle are moving around an axis passing through itself. Such a motion is called rotational motion. So even though cycle is moving in a straight line, the wheels undergo rotary motion. Second question, a tailor does not use a scale to take your body measurements. He uses a measuring tape. Why? Answer, it is not possible to measure body parts like circumference of chest, waist, collar, etc. correctly by using a scale, as these parts are not straight. A tape is convenient because it can be bent easily and used for correct measurements of such body parts. Third question, why cannot a sundial be used to measure time throughout the day? Answer, in hint itself answer is given. The sun may not be visible due to fog or clouds during day. It is not possible to measure the time during night. So during the day, if clouds and fog is present, we may do not able to measure the time, and in the night time also we cannot able to measure the time with the help of sundial. Section K, HOTS questions. First one, when you are traveling in your school bus, the person sitting in front of you seems to be at rest throughout the bus is moving. Second one, multiples and submultiples of units of measurements are required for measurement in daily life situations. First one, when you are traveling in a school bus, the person in front of you seems to be rest throughout the bus is moving, because the distance between you and the person sitting in front of you does not change during movement of bus. So they seem to be in rest with each other. Second one, multiples and submultiples of units of measurement are required for measurement in daily life. Answer, when we express distance between Delhi and Patna, it is far and more convenient to express in kilometer, multiple of a meter, not in meter. So Delhi and Patna distance, we have to express it in kilometer. Similarly, the length of a pencil is expressed in centimeter, that is sub multiple of a meter, not in meter.